Hello students, welcome back to my channel. Today we'll study the topics of ring theory. That is, we will discuss if K is any field containing an integral domain, then K is isomorphic to the field of quotients of D, which in turn implies that field of quotients is the smallest field containing D. Another problem which we will discuss today will be if D is an integral domain such that a raised to power n is equal to b raised to power n and b raised to power m is equal to a raised to power m for relatively prime integers m and n, then it implies m is equal to a is equal to b. And this result does not hold in the case if D is not an integral domain. Now let's get started. Now let's discuss a problem which states prove that if K is any field which contains integral domain D, then K contains a subfield isomorphic to F, where F is the field of quotients of integral domain D. इससे हमें क्या पता लग रहा है that F is the smallest field containing D. क्योंकि अगर कोई और फील्ड हम लेते हैं that contains D, then जो वो फील्ड होगा it would be isomorphic to a subfield of F, and hence F is the smallest field containing D. Solution: define a map phi from F to K such that phi of A, B, क्योंकि फील्ड ऑफ क्वेश्चंस के एलिमेंट्स तो इस टाइप के दिखते हैं ना, is equal to AB inverse since A and B belongs to D, which is a subset of K according to the condition given in the question. We also know that B is not equal to 0 क्योंकि तभी इसमें ऐसे एलिमेंट्स डिफाइन हो सकते हैं. Therefore, B inverse exists in K. Now, phi is well defined and as well as 1, 1. How? Let's see. A, B is equal to C, D, suppose, which implies that A, B is related to C, D, which in turn implies that AD is equal to BC, which in turn implies operating B inverse and D inverse. So it would be like A B inverse is equal to C D inverse, which in turn implies phi of A, B is equal to phi of C, D. इससे हमें पता लगता है that it is well defined. And similarly अगर हम यहाँ से start करेंगे and reverse कर देंगे steps को, उससे पता लगता है that phi is 1, 1. Alright. Now अब इसकी रिंग होमोमॉर्फिज्म चेक करने के लिए क्या करेंगे, हम दो एलिमेंट्स ले लेंगे A, B and C, D suppose. So A, B plus C, D is equal to phi of AD plus BC over BD, which in turn implies AD plus BC into BD inverse. Now it implies that AD D inverse B inverse plus BC D inverse B inverse, which in turn implies AB inverse, ये अगर B inverse cancel हो जाएगा, identity बन जाएगा CD inverse, which in turn implies phi of A comma B plus phi of C comma D. Addition तो preserve हो रहा है इसमें, और multiplication देखते हैं that whether it is preserved or not. So let's see. Phi of A comma B dot C comma D is equal to phi of AC comma BD, which in turn implies AC into BD inverse, that is AC D inverse B inverse, which in turn implies AB inverse CD inverse, which in turn implies phi of A comma B into phi of C comma D. Hence phi is 1-1 ring homomorphism, which implies that F will be isomorphic to phi of F, which is a subfield of K, and hence a quotient field is the smallest field containing the integral domain D. Now let D be an integral domain such that A comma B belongs to D, AN is equal to BN and AM is equal to BM for M and N का GCD 1 है, that is M and N are relatively prime integers. Then we have to prove that A is equal to B. इसका solution क्या होगा हमारे पास? If A is equal to 0, then it would imply AN is equal to 0, which in turn implies BN is equal to 0, which in turn implies B is equal to 0. Therefore, A is equal to B. Similarly, if B is equal to 0, we would arrive at the conclusion that A is equal to 0 and hence A is equal to B. Therefore, we assume that A and B are both non-zero. F, B, the field of quotients of D, and let phi be a map from D to F, be an embedding map, because we know any integral domain can be embedded into its field of quotient. Suppose phi of A is equal to A1 and phi of B is equal to B1. Now M and N का GCD 1 है, they are relatively prime integers. There exist integers x and y such that mx plus ny is equal to 1. Phi of A is equal to A1 is equal to A1 raised to power mx plus ny, which in turn implies A1m into x, A1n into y, which in turn implies theta of A into m, theta of A into n, ये into x and ये into y है, because A1 was given to us to be theta of A. A1 raised to power m is equal to theta of A raised to power m, which in turn implies theta of A into theta of A, so on up to theta of A, which in turn implies theta of A into A m times, which in turn is equal to theta of a raised to power m. A raised to power m is equal to b raised to power m, theta of b raised to power m, which in turn implies b1 raised to power m. And hence यहाँ से हमें क्या पता लग रहा है that phi of a is equal to b1 raised to power m x, and similarly b1 raised to power nx y, that is b1 raised to power mx plus ny, that is equal to b1. Now, which in turn is equal to phi of b, which gives us that a is equal to b as phi is 1 1, क्योंकि embedding मैप क्या होता है 1 1 homomorphism, hence our result is true. ये हमारा फील्ड ऑफ क्वेश्चंस कैसे यूज हुआ इसमें, जो हमने A1 और B1 के साथ किया वो हम A एंड B के साथ नहीं कर सकते थे, बिकॉज A एंड B आर एलिमेंट्स ऑफ इंटीग्रल डोमेन while A1 and B1 are elements of field of quotients. Because in integral domain existence of multiplicative inverse is not assured, और A1 B1 field के members थे तो we can talk of their inverse elements, and x and y integers जो हैं वो नेगेटिव भी हो सकते हैं. So solution हम उसका ऐसे नहीं ले सकते थे that a is equal to a mx plus ny, which in turn is equal to am into x an into y. अब x and y अगर नेगेटिव होंगे तो उसका क्या मतलब होता है, इनवर्स की पावर करना. एंड इनवर्स हमें नहीं पता कि इंटीग्रल डोमेन में मल्टीप्लिकेटिव इनवर्स एग्जिस्ट करता है कि नहीं करता, इसलिए हमने a1 पे वर्क करना किया. a1 belongs to the element of field. Show that the result of the above problem may fail if D is not an integral domain. इसके लिए हमें कोई काउंटर एग्जांपल लेना पड़ेगा. उसके लिए हम लेते हैं D is equal to Z8 addition and multiplication modulo integral domain 0 1 up to 7 mod 8. इस केस में हम ले लेते हैं A को 2, B को 4, N को लेंगे हम 3, M को लेंगे हम 4. N का GCD 1 है हमारे पास, and A raised to power N, that is 2 raised to power 3 is equal to 8, that is 0, and B raised to power N, that is 4 raised to power 3, this is also equal to 0, which in turn implies An is equal to Bn. A raised to power M, that is 2 raised to power 4, is also equal to 0. 2 multiplication modulo 2 into multiplication modulo 2 into multiplication modulo. Therefore, this forms 8, and 8 हमारा 0 होता है, तो therefore 0. B raised to power M is equal to 4 raised to power 4 is also equal to 0, and hence AM is equal to Bn. But A is not equal to B. Here हमें पता है that D is not an integral domain. क्यों integral domain नहीं है? Because 4 multiplication modulo 8 into 2 is equal to 0, where 4 and 0 are non-zero elements. Hence, D is not an integral domain. Thank you.